the delay between slides as we talk today. I'm going to start out, before we talk about bats, I just have two quick slides about the National Park Service to give yourselves a little context for me and the program that I'm involved with. I'm going to read to you here the mission statement of the National Park Service. The National Park Service preserves unimpaired the natural and cultural resources and values of the national park system for the enjoyment, education, and inspiration of this and future generations. I have highlighted in there a phrase in green, preserves unimpaired the natural and cultural resources. There's a lot sort of in writing on that, those few words. And it's because it sort of entails or implies that you have some knowledge of what where the resources are on their trajectory of health. And that requires us to look after them as much as it does to sort of learn about them as much as it is for us to look after them. And to that end, the National Park Service as a whole has a program embedded inside of it called the Inventory and Monitoring Division. And this is the group that I work for. We basically divides the parks, the national parks in the country up into 32 different networks. The parks in those networks are all sort of ecologically similar to each other, which is why the map on the left looks sort of hodgepodgey or camouflagey. It's a way of grouping the parks so that their ecology is very similar, and as such, the research, the monitoring that we do in those parks is attributable or a common thread among those parks. And then it can be spooled up at regional levels or at national levels. So we're sort of the group that watches after the resources, basically long-term monitoring. We do everything from water to forests to birds, mammals, rocky intertidal, wetlands, air quality, water, and like even light pollution. And so just as a context, that's the program I work in. The National Park Service has this to help sort of inform itself and what its resources are. But today I'm going to talk to you a little bit more about something pretty fun, and that is bats. And we're going to do this as sort of engaging and sort of interactive as we can with everybody on the call. It's basically going to be a quiz, but nobody should get very nervous. It's not very hard, and there's nothing really at stake here. But I'm going to walk through 10 questions over the course of the hour I have with you. And we're going to walk through them together. First ask the question and then see how you guys do. And then we're going to have, I think Joey and I have decided we're going to try out having folks type their answers into the chat. So I'll just give a few seconds after each question for folks to try and answer it. And we'll sort of just do a general consensus and move through that and talk a little bit about the answer. So let's get started. So question one, I'm going to start you out here real slow. Bats are A, birds, B, mammals, or C, neither. Get you warmed up. So I'm seeing the answers coming in already. And we've got mostly the bees have it, which is great. So that's good. We're off to a good start. And yeah, it's true. Bats are in fact mammals. Much like humans, they give birth to relatively undeveloped young. They feed their young with a pair of pectoral breasts. They feed them milk like all mammals do and are covered in hair. And in fact, the similarities between humans and bats were so strong that Carl Linnaeus, he was a Swedish botanist from the 1700s. He's also sort of the father of modern taxonomy, scientific taxonomy, naming of species and genuses and the groupings of those. He was impressed so much by the similarities of bats and primates that he actually put them in the same taxonomic grouping, and that was the primates. Today, we know a little better that we don't, in fact, share the same taxonomic group as bats, but that we do share a common ancestor, sort of back in the relatively closely to a shrew.
Excuse me, Adam?
Oh, yes, of course.
I'm one of the participants, and I just wanted to let you know that every time you move your head away from the mic, you're fading out.
Oh, good to know. All right, well, I'll hold it up a little closer to myself. Thanks for that. I appreciate that.
You're welcome.
I hope this helps. Please tell me again if it isn't. So again, basically we do share a common ancestor. It was a sort of a flying shrew of sorts, or a gliding shrew. And in general, although they're different, the fact that we share a common ancestor at this point would still make Linnaeus pretty happy that he was so close. That was over almost 400 years ago. So this is a good time to talk a little bit about sort of the life cycle of bats. We're going to start off here in the fall, late fall. And basically this is when, for bats, courtship and mating occurs. Basically this is occurring now because they have the sort of the highest level of sort of physical fitness involved. They've come off of a long summer, hopefully, and have been eating well all summer. In falls when the males and the females will go through their courtship. And that's leading into our next step, which is where we are now in the life cycle, and that is winter. Now, winter, there's really two ways to deal with winter when it comes to, in particular, if you're a bat. Option one is you have the opportunity to migrate. And what that really affords you to do is deal with the drop in food and the drop in temperature by going somewhere where there is more abundant food and there is more favorable temperatures. So I think a lot of you can probably relate to this particular strategy when winter comes, and particularly as winter gets long in the tooth. The idea of going somewhere that's warm and that food is abundant and easy to come by is very attractive. Bats basically have the strategy of doing the same thing. A number of the species, even the ones that live in Vermont and in New Hampshire, there are 3 of them that actually will use this migration strategy to move farther south to basically, combat drop in food and drop in temperature by going someplace where those aren't a problem. Option number 2.
Hey, Adam, you're still going
Yes.
going in and out at some times.
Okay, I've got them. Joey, do you hearing this? Are you hearing the same thing?
Yeah, it's occasionally going in and out, getting really quiet. Maybe hold the mic up a little bit closer if you can.
Yeah, it's right in front of me here. So this is the best it's going to get, I'm afraid.
Yeah, we'll see what we can do.
Okay, great. Option number 2 is to hibernate. And again, you have the same 2 problems. You have drop in food and you have drop in temperature, but hibernating is an entirely different strategy. And there's basically 2 things that are going on here. One is that you need to manage the amount of resources you have, or food, calories, basically. And the other thing is you have to sort of manage the rate at which you are burning through that food resources. So in the case of bats, our typical North American bat weighs somewhere between 5 and 15 grams. So that's, think about a US quarter. In the fall, they basically undergo the strategy of putting on about 25% of their weight. And you could ask, well, why don't they put more on? Well, they're a flighted mammal, so they have certain weight requirements. The same way you can only put so much luggage and people on a plane, you can only put so much winter weight on a bat before it is unable to fly anymore. So it has sort of an upper boundary restriction to how much weight it can put on. And that puts it in a pretty risky position. It has to put on just enough weight that it has the extra resources and energy to make it through the winter, but it can't put on so much weight that it, it sort of violates the laws of aerodynamics and can't fly anymore, so that would be too much. So it has a very fine line there that it wants to put on enough, but not too much. And that's about 25% of its body mass. And then the other thing, and that I would argue this is probably the more important of the 2 things as far as the strategy goes, is that then it has to find a way to regulate how fast it's going to be burning through that energy. Think about fuel in your gas tank. You can make the fuel last longer if you go slower. If you drive around in a really fast rate, you're going to burn up the fuel fast. So they want their rate of burn to go way down in the winter. They want to drop their metabolism. In North America, you're looking at about 180 days where there's lack of food. Basically, insects is the primary food here in North America. And so you need 180 days worth of energy. So the rate at which you're burning it against the amount of time that you're going to be without food is basic formula that is being worked out here. And in the case of bats, they do this by dropping their body temperatures from about 100 degrees Fahrenheit all the way down to an ambient temperature of about 35 to 41 degrees, which is pretty spectacular. And more than just their body temperature, they're dropping everything else about their metabolism. So their heart rate can go down to about 5 beats per minute, which is pretty amazing. That's a beat every 12 seconds. And their breathing can go down to one breath per 15 minutes. So they're really going down to most people I think would recognize this as a dead animal, being that it was cold and hardly breathing or its heart was beating. But this brings its basic burn rate down to such a low level that it can use that 25% of extra energy to make it through the winter. How does it do this? I mean, how do you just lower your body temperature? Well, that's all about finding a place to live. It really relies on the place to do that. And those are called hibernacula. So a hibernacula is a site that has a very cold, steady, very specific temperature. And the bats basically go there and allow their body temperature to drop to the ambient temperatures. So this is why caves are often considered very high value sites and very important. You can see that there's a very narrow range of sort of acceptable metabolism that can occur. If this cave gets a little warmer or a little colder, if the bats can maybe not make it through the winter. If it gets a little colder, the bats have to shiver or burn energy to make more heat, and they run out of energy and die before the insects come out in the spring. If the cave or site is a little too warm, they again burn more energy, are unable to keep themselves at the colder temperature, and they run out of energy also. So they have very, very specific sites that they'll roost at for the winters. So that's our hibernation migration part of this cycle, and also a little bit of discussion on Hibernacula. So that brings us back into spring, which hopefully will be in here in another month and a half. And that is depending on what strategy you use, whether you migrated south or you overwintered in a Hibernacula. This is when you would either be coming back to the area via another migration back north, or you would be waking yourself up from hibernation, which is called an arousal. When that happens, that's generally in the females when fertilization or implantation occurs. And so, I mean, I know folks, probably everybody on the call is familiar with the birds and the bees at this point, but to have courtship and mating in the fall and fertilization and implantation almost 6 months later in the spring is pretty unusual, or it should strike you as unusual anyways. And I wonder if anyone can maybe think a little bit. I'll give you a second to think about why bats might do that. Now, the main reason I gave a little bit of clue to it before is that in the fall, bats are at their peak sort of performance. They're at their peak body condition. And courtship and mating is very energy intensive. There's a lot of showing off by the males, you know, to make sure that the females are picking good mates. And there's a lot to do with fitness at that point. And so you want to be, you know, going through your courtship and mating process while you're at peak fitness. Winter is one of the most stressful times of the years for bats as far as energy reserves and all those sorts of things of making it through to spring. And the condition at which you arrive in spring has a lot to do with that. So females will actually delay fertilization and implantation to spring to wait to see what condition they come out of in the spring. And so they can actually have control over, if they're in too poor of state, not to go ahead with a pregnancy, which is pretty powerful with regards to evolution. It gives them a lot of control over their own health and the health of their offspring. So once you have a pregnant female, we have a sort of, this is a mirror image to a hibernacula, but in the summer, bats rely on what's called a maternity colony to produce conditions, temperatures and conditions that are most suitable for baby bats. Basically, as a maternity colony, think of it almost like a nursery colony, where the winter hibernacula or winter roost takes care of a bat by making sure it stays the right temperature, and that's a really cold temperature. Maternity roosts do the same thing, but the other end of the sort of thermometer. You want a really warm, stable temperature because bats, like you see here in the picture in the lower right, are born without fur and helpless with their eyes closed. And the females still need to go out and feed. You know, the males don't bring food to them to process the way birds do. The females need to go out and feed. And so they have to leave the babies in the maternity colony. And so the maternity colony needs to act like a giant mother in some cases. And so that nice big warm hot building where all your females are in a lot of cases here in the Northeast in particular are again very specifically chosen for the conditions and temperature and the benefits that they offer to the bat. At the same time, not all bats want to be in 110, 115 degree maternity roosts. They can be very metabolically stressful too. You know, you get dehydrated and you're always overheated and you're running a really high metabolism. So if you're not a pregnant female or you're a male, in a lot of cases, these will form bachelor colonies and separate themselves from the females. This does two things. It puts them in just sort of normal temperature ranges, which is easier on them. But two, it separates them from the females that are foraging at night. And so it separates them on the landscape in a way that provides more of the food for the pregnant females around the maternity roost, while the males and the non-pregnant females can be at other parts in the forest or on the landscape feeding over there, and it helps sort of separate those two. So that works out really cleanly. Birth will occur about a month and a half to 2 months after fertilization, and bats will give birth to most bats will give birth to about 1 young. Some of the larger bats will give birth up to 4 young, 4 is sort of an extreme side, but most bats are around 1. They have to learn to fly in about 6 weeks. So it's a really short turnaround from being the little baby pup that you see on the finger and being able to fly. And then of course, like we talked about earlier, you probably saw this coming, they need to be able to put 25% body mass on right away, because if you're going to migrate or you're going to hibernate for the winter that's coming up, you not only need to have learned to fly, but you need to be able to learn how to take care of yourself, and you need to learn how to fatten up pretty quick because you're already waning into autumn and need to sort of re-engage in this cycle again. Now, the fascinating thing about this is that a typical bat will do this 20 times in its lifetime. They live to, on average, 20 years old. On the outside, or the oldest bats will live all the way up to 40 years old. So they're very long-lived for their size. They're very slow producing. Again, 1 young per female per year, often not starting reproduction until their 2nd year, but then they live for generally a relatively long time, which if you think about, I think most people associate bats with rodents and stuff like that. This is a different way of doing things. It's sort of unique in that way. So question number 2, now that we've got some of the basic biology out of the way, bats are members of what mammalian order? Are we looking at A, the Insectivora, B, Artiodactyla, or C, the Chiroptera? I'll give everybody a couple seconds here to pop in and answer. Okay, great. We have some folks that have no idea, which is great. I'm glad you're here. And well, we also have a lot of C's, so that's wonderful. So you guys are right, Chiroptera. It actually is Greek, Greek for hand wing. You can see here a comparative morphology picture, basically of the same bones in both a human arm and a bat wing, to sort of give you some idea. I mean, it looks like such a foreign thing, a bat wing. You can see particularly in the black and white photograph there, the bones are highlighted nicely. And they look so alien that it's hard to imagine that that's has a sort of a correlate with our particular architecture. But it's actually a lot more straightforward and simple than you might think, with humerus in purple, radius and ulna in green and orange, and then all the finger bones in the various colors leading out. Basically, the architecture is such that if you were a bat and you put your arm out to your side and you dangled your fingers from chest height, your fingers would be touching the ground. So the fingers are the majority of what sort of supports the wing, and that gives them a lot of dexterity, right? So the same amount of dexterity you have in your fingers, the wiggle of your fingers, you stretch a membrane between those, and all of a sudden you've got a wing, not like a bird, which is just feathers attached to long bones, but you've got a lot of extra sort of control because of all the fine motor skills and movements that you can make to those fingers. So, bats, flying mammals. Bats are in fact the only flying mammal. Where did they come from? I mean, how do you go from what looks like an arm or from a ground-dwelling, animal that was walking on all fours to an animal that can fly through the air? I mean, that seems like a pretty big step. And in fact, it's sort of interesting in the fact that the fossil record 50 million years ago, bats showed up looking about like they do now, like you see on the screen. The fossil record shows bats as having, fully, formed wings and arms where the skin was stretched between them. And so we know that they came on the scene pretty rapidly. In 50 million years ago was a long time. Around 66 million years ago, there was a relatively large event that I think, even if you don't know the number, 66 million years ago, you may be more familiar with it as this particular event. So the difference between the Cenozoic era, which is where bats were formed and found fully fossilized with wings already, and the Mesozoic era, the differences between those two eras was the cataclysmic event. Basically the comet or asteroid that struck the planet and led to a major extinction event of dinosaurs. That particular extinction event had a lot of sort of downstream effects in the sense that it killed off all the sort of non-avian dinosaurs. And as a result, there was a lot of open niche space. Basically a large 75% of the planet's species disappeared, and there was a lot of room for other things to sort of take their place and evolve into it. And so that's sort of the hallmark of the Cenozoic era as a whole, is the radiation of mammal diversity. and lo and behold, that's about when the bats show up also. So I suppose we can thank the comet that struck the Gulf of Mexico for bats.
Hey, Adam, you might want to try turning your video off. You're starting to freeze up a bit, so that might help free up your bandwidth.
Yeah, okay. All right. Hopefully that helps. So question number 3, how many species of bats are there in the world? Are we looking, and these are just powers of 10, so hopefully relatively straightforward. 13, 130, or 100. We got a lot of smart people in the group today, so a lot of C's coming in, so that's great. Yeah, so there's just under 1,300 species of bats on the world and the planet. That makes 1 out of every 4 mammal species a bat, actually. As far as New Hampshire and Vermont is concerned, we're looking at 9 species in Vermont and 8 in New Hampshire. And we'll talk a little bit more right now, in fact, about those particular 8 or 9 species. So I'm going to break these into 2 categories, and I'm going to give you just a really quick sort of view, a picture, a mugshot, so to speak, of each of these species to give you an idea of who you're sharing your state with. As far as the cave or hibernating bats are concerned, we've got the big brown bat, sort of the coyote of the bat world, or red-tailed hawk of the bat world, so to speak, a nice sort of general all-around generalist, good at a lot of things, different habitats, a lot of food resources. Relatively large bat for the bats that we have here in the state. Little brown bat, probably one of the more famous, or one that people were familiar with 10 or 12 years ago because it was super abundant and found in close association with people, but has since taken it really hard population-wise with over 90% population drop because of white nose syndrome, and we'll talk about that in a little bit. The Indiana bat, and this is the bat that's different between Vermont and New Hampshire. It is found in the southwest corner of Vermont, but does not make its way over to New Hampshire. Tricolored bat, another bat of the Myotis species, Myotis genus, as well as the northern long-eared bat and the eastern small-footed bat. So those are our cave and hibernating bats found in New Hampshire and Vermont. But we also have 3 tree bats or migratory bats. And these are sort of larger body size, heavily furred. They don't rely on sort of communal roosts. They're solitary bats. And so also do most all their roosting either in trees or on the ground, and tend to deal with winter via the migratory routes. They fly the long distance to get out of winter's hardships. So number 4, where do bats roost or sleep? So we were just talking about that for some of the tree dwelling bats, but what about this particular question? So F, so we got some all of the aboves. Excellent. Yeah, that's true. Tons and tons of diversity with how bats make a living with regards to roost and sleep. They can be found in almost every conceivable shelter, and many that now live in buildings, which is probably the way most people become familiar with a bat, is when they take up residence in a barn or a house. A lot of those are doing that now because they have limited other alternatives. They've lost other roost sites or habitats, so are using homes and houses. Tropical species tend to occupy a wider range of roost sites. And several species even have suction cups or suction discs on their wings and feet that enable them to live on the slick-walled cavities of like leaves, like the center picture here shows, like inside of the banana plants. And yet there's some even more bats that live in animal burrows or flowers, termite nests. There's one bat that specializes in living in large tropical spider webs. So a ton of diversity when it comes to where bats roost and sleep. What do bats eat? Insects, nectar, fish, none of the above, all the above? Fantastic. Great, guys. All the above, again, with the diversity theme here, with 1,300 ways that bats are making their living. 70% of all bats do eat insects. So, insect-eating bats, in particular in North America, all but 3 of the species in North America. I think there's about 47 species in North America. All but 3 of them are insect eaters. The other 3 are nectar feeders along our Arizona-Texas border with Mexico. But it gets pretty interesting when you get out from North America into the rest of the world. You know, a lot of them are fruit and fruit eaters, and as a result, really strong seed dispersers. We have a number of them that are feeding on nectar and specialize in the plants have evolved to use nighttime blooming flowers to specifically create food and attract bats to help pollinate them. And then you have some really interesting bats like the fishing bat, which is the center of the bottom, which has evolved really long fingers and sharp talons, and they fly close to the water surface and can actually detect the ripples of the water of fish close to the surface. And they'll come down with their hands and sort of just lick the water and fish. So speaking of how bats catch their food, how do the insect-eating bats catch their food? You know, here they are flying around at night with small insects zipping around them. Are they just going to catch it straight into their mouth like a swallow would during the day, or are they also using other parts of their body like the tail or the wings? We got a little bit more of a mix in answers here, which is good. So I'm going to tell you that it's all of the above, which is pretty interesting. In fact, the animation on the screen sort of maybe is a little evocative of how, if you guys have ever sat out at dusk and watched a bat fly, how incredibly erratically they fly. You know, it's not like watching a bird going from point A to point B. They're fluttering all over the place. And a lot of times that is because they're feeding. They're very active feeders, like I mentioned before, because their hands are their wings. They have a lot of dexterity and can do some pretty spectacular aerodynamics. And to add on top of it, they are, for a lot of ways, using their mouths, trying to catch insects directly in their mouth. It's very efficient, and in particular when they're looking for small prey, like small moths or mosquitoes or something of that nature, or gnats, they're going to be catching it in their mouth. But a lot of times, particularly if the insect goes into some sort of last-minute evasive maneuver, or we're talking about a larger prey like a June bug or something like that, they will often catch it in their tail or the wing membrane, and then on the wings sort of fold up on themselves and sort of pass the food item into their mouths so they can bite and kill it or process it the way they need to. And so that sort of leads to a lot of that really sort of fluttery movement, is that they're sort of like maybe like a baseball player catching things, you know, left and right with all different parts of their body and then passing it into their glove or their mouth. And so it leads to some of that erratic behavior. How do bats find their food? By smell, sight, sight and sound, or all of the above? Great, got a lot of D's and C's, a few question marks, and that's good because, again, all of the above, not to get stuck in a rut here, but bats are incredibly resourceful in what resources they're using to catch their food, in particular with the different kinds of food that they're going after. Like again, we saw the nectar feeding bats going after food, flowers and fruit, while we have our insect eating bats, which in often cases are using sound and echolocation. And also, you know, a lot of we have some diurnal bats, like folks I'm sure have seen flying fox pictures from the Pacific South, which are large diurnal bats, which use primarily their eyesight because they're active during the day. But I want to talk a little bit more about the sound part and the term of echolocation. This is an absolutely hands down fascinating topic. And it's also something that bats specialize in, and we should talk a little more about it. So in 1938, there were 2 researchers, Donald Griffin and Robert Galambos. They were actually undergraduates in 1938 at Harvard University, and they started looking into sort of animal behavior, and in particular bats, and how they were, how bats, you know, located food and or navigated at night. And they were fascinated by this. And as they slowly gathered more information by studying the bats, by 1944, they had coined the term echolocation. Today, it's a relatively common thing for us to think about, but at the time it was a super unique, topic. And the way it works is basically the bat produces a pulse of sound and it tends to be a very loud pulse and sound. In this case, it's ultrasonic, so we can't hear it. And it's lucky we can't, because it would keep us up at night. It's so loud. And that energy wave travels out and then bounces off of objects in the bat's environment. And those echoes, or those sound wave bounces, come back to the bat, and they're able to get information from that. And actually, go ahead and navigate either in their environment around obstacles, or even use it to the extent that they're chasing their prey using echolocation. Now, I want to read a super brief paragraph about Donald Griffin, because, you got to imagine, before I do that, I want to maybe just another quick quiz here. What else was happening in the world between 1938 and 1944? That was a pretty big event. So to place a little context for the time of the century that he was discovering this, World War II, exactly, everybody got it. So World War II was going on, so it was a really big deal. So here's a couple of bat researchers at Harvard, and there were also an incredible number of engineers, both on the German side and the American side, trying to reach for the next technology that would win the war for them. So let me read you this quick little excerpt. Donald Griffin tells a story of what happened when he and his colleague Robert Galambos first reported to an astonished conference of zoologists in 1940 their new discovery of the facts of bat echolocation. One distinguished scientist was so indignantly incredulous that he seized Galambos by the shoulders and shook him while complaining that we couldn't possibly mean such an outrageous suggestion. Radar and sonar were still highly classified developments in military technology, and the notion that bats might do anything even remotely analogous to the latest triumphs of electronic engineering struck most people as not only implausible, but emotionally repugnant. So it was, the fact that bats were doing something that human engineers had spent a lot of time and energy to develop and was considered top secret was just like this, an oxymoron that a lot of people couldn't wrap their minds around. But Donald Griffin and Robert Galambos were correct, and echolocation is in fact how bats navigate and or find food. And as such, I want to give you a little bit more information on that, because what might be going through your head now is like a bad World War II movie where there's a yellow or green line on a circle going around, and occasionally a blip will show up that says something is out there. And you may think, oh my gosh, how crude must it be to be able to see things using sound echoes? Well, I want to quickly give you a little bit of background information on sound echolocation. And there's a lot of information here, but I want to focus on sort of the rate at which things are happening. So sound echoes are actually happening in packages, right? The bat has to call, so that's a specific package. You and I walk around in daylight by the sun, and the sun is giving us constant information. It's more like a video rather than giving us a series of pictures in a row. The bats get pictures in a row, and they get those pictures at the rate that they're calling. So they're sending out, when they're basically just cruising around, they're sending out 10 bursts a second, 10 calls a second. So they're receiving 10 pictures a second coming back from different echoes. So you might think, well, what does that look like? How can I wrap my mind around what that might look like? Well, 10 bursts a second can be about what a machine gun does. So if you can imagine the noise of that noise of bursts, that's about how many pictures a second or how much information they have the capability of bringing back to them. So that's pretty impressive. You're thinking, well, okay, that's maybe not so bad. If I'm getting 10 pictures a second, that's a pretty high rate of return. Maybe, maybe they're seeing a little better than I'm giving them credit for. Well, when they're hunting though, they ramp things up to 200 bursts a second. So the closest thing I can come to this to help you with this, sort of envision this or get a picture of how much information this might be, is actually, I don't have to go any farther than a complex fluorescent light bulb. So complex fluorescent light bulbs, and you guys probably never saw this coming, but we're going to talk a little bit about electricity. The US main, the way that we generate electricity using generators is to spin large magnets through wire coils. And we use, obviously different power sources to do that, but the basic engineering is the same. When that magnets spin through those coils, it produces a voltage curve that has a peak and a trough in it. But that also means that it's crossing through the zero line twice during that period of time. And so you're actually producing zero electricity twice during a typical 60 hertz second, where you're moving from positive 110 volts to negative 110 volts in polarity. Now, why am I telling you this? Well, what it means is that our electricity system, the outlet into the wall of your house, is actually surging in power from 110 to 0 to -10 twice every 60 seconds, meaning 120 times a second. So when you plug a complex fluorescent light bulb in, which works on that power, it's actually blinking at 120 times a second. The human eye can't pick that up, so it looks like a constant picture. So bats are looking at 200 bursts a second. When you're in an office space or a house with no windows and the only light in that room is a complex fluorescent bulb, you technically are looking at the world at 200 pictures a second. So bats have a basically consistent view of their world, particularly when they're hunting. That takes a lot of energy to call it 200 bursts a second, so they're not always using 200 bursts a second, but even when they're just cruising, they're using 10. So hopefully that gives you a little perspective on what it might look like to use echolocation to move around the landscape. Real quickly, bats use echolocation in different ways. We talked about the diurnal flying fox. It's the center bat in the top row, but you see these other bats have these pretty spectacular morphologies associated with their face. And basically their faces are acting like large radar dishes in some cases, particularly the one in the upper right. They look a little owlish to you, and that's not by accident. Owls are also using sound to hunt their prey, and so the disc facial structure of feathers on an owl serves a very similar purpose. This bat's face and ears are all built to be like a little dish, whereas other bats would use just giant ears like the one in the upper left. So you can almost go around these series of pictures and you could almost incorrectly infer how important bat echolocation is or sound is to any of these particular bats just by looking at them. And I think that's pretty neat. So you can see that the nectar feeding bat with his tongue out doesn't have very large ears, although it flies at night. Again, it's using some echolocation for basic navigation, but it's using mostly smell. It has a nice long nose. The diurnal bat in the center up, again, is the flying fox, almost has large eyes that it's using. Again, ears, not such a big thing on it. So echolocation is not a big deal, whereas the other four have some pretty dramatic facial structure that's leading to larger growth or larger ability to do echolocation. So kind of a fun way to look at any bat picture and be able to tell right away whether it's an echolocating bat or not. Question number 8. So we're making good progress. What are bats good for? Eradicating disease, pollinating fruit trees, fertilizer production, just part of the food chain, aesthetic value, or all of the above. Yeah, people are catching on a little bit that I like the all of the above category. So yes, all of the above is, again, the answer, again, with amazing amounts of diversity. There's also lots of different things. Eradicating disease is a really quick, fascinating story I'll give you. Bat houses were not always really mainstream. In fact, it was right around the turn of the century that sort of the first bat houses were being built. And it's a really fascinating story. Dr. Charles Campbell down in Texas basically was a doctor, a medical doctor. He was interested in eradicating malaria, and he thought maybe if he could colonize bats the way you almost like keep bees, that you could maybe affect the amount of malaria on the landscape. And so what he did is he built these large tower structures out on the plains on the Gulf in Texas to attract bats. Now the picture shows a couple of really interesting things going on here. Basically, here you've got this truck, which is actually laden with bags of guano. So one of his sort of positive sides with not only the malaria aspects that you could produce a lot of fertilizer out of these towers, the bats themselves would enter through these louvered fronts here. And there's lots of slotted pieces of wood inside these towers. And because it was a tower, they could come raise or lower their location based on how hot it was outside. So it was really suitable. And then any guano that they deposited would rain out down onto this concrete pad that they could then sweep up and harvest. And then of course, it was up on legs with these predator guards on it to prevent raccoons and other mammalian predators and mesocarnivores from getting up and bothering the roosts. So these roosts were really, really successful. They were successful to the point that actually the state of Texas nominated Dr. Campbell for a Nobel Prize in medicine for this. But the one last character of this tower that I think is the most important, of course, is of course the Christian cross at the top, because that keeps the bad bats out. So like, there's certainly always a lot of mythology and mythology surrounding the bats, and it was no less here. They put up bat towers, but they thought it was also important to put up a cross on the top, which I think is fascinating. So pollinating fruit trees, again, huge thing for that. Really quick example is the baobab tree in Africa, tree of life, only pollinated by bats. So that tells you something. The tree is so important to wildlife that they named it the tree of life, and bats pollinate it. So they play a huge role in a lot of many parts of the world. And in fact, bananas, avocados, dates, figs, peaches, mangoes, clove, cashew, balsa wood, all rely on bat pollination. Fertilizer production, like I mentioned earlier, collecting it under malaria-inducing houses, but it was also is a really big part of. It's a really high in nitrogen. It's still a modern fertilizer nitrogen source, and it was even used during the Civil War when they were running low on gunpowder. It could be mixed with sulfur and charcoal to make a crude gunpowder. So again, so fertilizer production seems like a silly thing that bats would be good for, but in fact, can be 6, 8, 10 feet deep in some of these long-term roost sites that are found in Central and North America. Just part of the food chain. I showed you pictures earlier of bats eating lots of other things. Well, lots of things eat bats too. There are falcons that prey on bats at dusk, waiting for them to come out of their roost. Owls prey on bats. Even frogs eat bats. And aesthetic value, not to underestimate or list it last, but bats, again, like I mentioned, have had a nice mythology, both good and bad, with regards to over the centuries, and they show up in artwork, and there's even examples of them on postage stamps and that sort of thing. So they play a sort of in general, a role of fascination for us as humans. Question number 9, is conservation of bats important? Yes or no? This is the one question I hope everybody gets right. Question. The answer, of course, is yes. Unfortunately, though, globally, out of the almost 1,300 species, we've got a significant number of them that are critically endangered, or vulnerable. Even at a national level, that number even starts to go up a little bit in the sense of percentages. Of the 47 species in North America and US and Canada, about 30% of those are listed on our endangered species lists. And locally, you might ask, of the 8 or 9 here, almost 50% are either on our state or federal T&E lists. So our bats need a lot of help, particularly here in the Northeast. Now, why is there sort of a gradient here between globally up till locally that things are almost doing worse here than they're doing anywhere else? Well, one of the answers is, in fact, white nose syndrome. What is it? How does it affect bats, and where does it come from? I'll give you a quick little primer here. It's basically a fungal-induced disease caused by a fungus called Pseudogymnoascus destructans, or PD for short. PD is basically a cold-loving fungus growing in the caves, and so it has been strongly affecting all of our cave hibernating bats. The picture on the right is a black light, and you can see that the fungus glows under the black light, and what ends up happening is the fungus infects the bat's skin, exposed skin. So the muzzle of the bat on the left, the wing membranes of the bat on the right get infected, and that are basically just highly irritating to the bats, and it causes them to wake up or be disturbed throughout their hibernation season. They end up burning up some of that valuable 25% fuel reserve they have, and they just don't make it through the winter. So it's had a really destructive effect on the populations. Like I mentioned earlier, some of the Myotis species, little browns in particular, have lost 90% of their population in the last 10 years. They went from the most abundant mammal in the Northeast to an endangered species, all within a period of 10 years. It was a pretty sad story. Where did PD come from? It's native to Europe. In fact, it's in all the caves there, and the bats coexist with it. So there is hope, and there is starting to be some evidence now that the disease has started to slow, and the bats, the 10% that did make it through the initial infection and death rate, have started to have some level of resistance, in the breeding and reproduction and replacement of those bats is coming back a little bit stronger. Now, we mentioned before that bat reproduction is really slow, so this is going to take a long time, and as it takes a long time, bats are going to be really, really vulnerable to other risks. So this was a pretty tragic event here in North America, and it's still ongoing. This is a very quick map. The entire infection outbreak started in the Hudson River Valley, just maybe 3 or 4 hours from here of us in central Vermont. And from there has spread to a large portions of the East Coast and Canada, and has even jumped over the plains, what are normally considered sort of the dry states, to the cold Pacific Northwest. So again, it's still spreading, but there are some signs here in the Northeast, where it's been here the longest, that bat populations are starting to show small but hopeful signs of recovery. So just really quickly, this kind of gives you a feel for, you know, like I mentioned, with half of our species in the state, and the fact that they're on the T&E list, and then you overline it with the fact that, you know, they're almost all cave bats, and you can see that white nose syndrome is really at the root of a lot of the conservation problems that bats are having currently right now, in addition to habitat loss and other things like that. So not to end on a sad note, because I refuse to do that, we're going to do one quick fun question here at the end, and that is, are vampire bats real? Fantastic, everybody. Good job. Yes, vampire bats are in fact real. There are 3 species of vampire bat in the world, and they're all in Latin America. And in fact, they've been found as far north as a train tunnel in Texas. So vampire bats have been in the lower 48 and have been found there before. Again, a really fascinating sort of example of the diversity of bats on the planet. To start, you know, everybody, the picture of Bela Lugosi there in the upper right, of one of our most famous vampires in Hollywood, of course. You know, Hollywood, as everybody knows, isn't always completely accurate, and you've got to sort of stretch your imagination a little bit to go along with some of the topics that they bring up. And Bela Lugosi is no difference to that, in the sense that you can see from the skull in the center of the picture that probably one of the most prominent parts about a vampire bat and what makes it work the best are these, it's cutting teeth, or it's puncturing teeth, that actually, where it cuts into and makes an incision to drink the blood, there are actually its 2 very center incisors or front teeth. So if Hollywood had wanted to be accurate, Bela Lugosi would have had to have been buck-toothed, and that would have been more biologically accurate, but probably not as popular to give him two giant front teeth. So what the basic way it works is the vampire bats will land either on the ground a lot of times, or especially with large mammals like domestic cattle and stuff, they'll actually land on their back or on the side of their body. And in either case, they will crawl to a place where blood is close to the surface, and then use those 2 very, very sharp incisors to make a very quick incision. Their saliva has antiseptic qualities, in the sense that it's analgesic qualities also, so that it has, the animal generally doesn't even feel the fact that they've been bitten. And then instead of sucking the way, again, Hollywood portrays, they'll just lap up the blood as it comes flowing out. Now, the picture here in the lower left is actually a female vampire bat. I actually caught this in Nicaragua when I was doing some rainforest seed dispersal work down there. And this particular female is actually full of blood when we caught her in the mist nets. You can see she's got this big sort of belly going on here. And what was particularly interesting to me is there's a tendon, and you can see it in sort of the colic of the hair that runs from her chest down to her groin here. There's a tendon that runs through here that sort of connects the skin. And when you put her on her belly, like she would be when she was flying, you know, you can imagine that, you know, the way they used to tie down cargo in sailing ships, if you didn't do that, when the ship yawned or turned to the side, all the barrels and boxes would roll to one side of the ship, and it made a high chance that the ship would capsize. And so you would want to secure all that weight. Well, you can imagine when you're a bat, and she's flying with up to 30 to 40% of her body mass in blood. You can imagine that when she goes to bank on a turn, all that fluid would swing to one side of her body and throw her into a tree or something like that. So they've developed this technique where they have this tendon that runs down the middle, and it's kind of like hanging a water balloon over a clothesline. You can imagine if you hang the water balloon over a clothesline, half the water's on both sides of the clothesline, and when you go to bank on a turn, basically you've sort of tethered a lot of that fluid and prevented it from being a problem to you. So a really cool technique. The other thing you can see about their morphology, which I think is interesting, is that they have really, really muscular arms, and it's just cut off here, but they have a really muscular thumb too. They spend a lot of time walking on the ground, basically stealthily walking up to something. And once they're on the ground and have successfully gotten a blood load, then they also need to be able to take off again. So they spring off the ground like a frog with their really powerful front arms. They jump into the air, 1 or 2 feet into the air, straight off the ground, and then they take flight from there. So again, a really cool animal, and definitely in a real thing, and it happens. And they're very, very common, and actually not really threatened in any way. They're doing very well in the parts of the country that they do live in. So yeah, that's the last little bit I wanted you guys to learn about bats. I think hopefully we've got a little bit of time here, and I think Joey and I will help manage and open this up to questions.
Yeah, thank you so much, Adam. We have 4 questions that popped up during your presentation. So I'm just going to go through them in sequential order. The first question that came up is, do bats that migrate also put on weight?
Yes, they do. It's same for birds too. So anything that's going to go on a long migration, they generally can't rely on the fact that there's going to be a lot of food, particularly every stop along the way. With birds, there's big way stations that are important to them. One of the famous ones is the Great Salt Lake system with all its brine shrimp in it. They migrate through the Great Salt Lake and will stay there a week or two and fatten up again to continue on their trip. Bats, it isn't really that well known that they have these large feeding stops, and they may feed, a little bit here and there along the trip, but they do rely a lot on their fat reserves to make that trip. They also use a lot of tricks, and they use a lot of the same tricks that bats do. They travel on very specific weather nights. The winds are favorable, the temperature gradients are favorable, there's lift being provided to them. They're using ridge lines that have that lift, so they can use as little bit of that precious energy as possible as they're flying. There's even bats that will fly really, really high up in the jet stream and use those air currents to help move them along too. It's also, unfortunately, the reason why bats and the wind energy systems have gotten a lot of bad press in the recent years, because wind turbines tend to be on these same ridge lines that birds and bats will use. And so there's been a lot of concern about bats and wind turbines because the turbines are being placed on their migratory paths. So there's a lot of work and research going into that also. So hopefully that's a little bit more than you asked for about the weight of bats, but yes, they do put on weight, and they do migrate, and they share a lot of the same characteristics of birds for that reason.
Awesome, thank you, Adam. So the second question is, do all bats use echolocation in some way, or only those hunting for insects and things?
Yeah, so it's sort of a gradient. I mean, there's not a clear answer there, other than there are a few bats that very hardly use echolocation at all. And those are sort of the large diurnal bats. Their entire life cycles during the day, they're feeding on large fruits. They can navigate their landscape using their eyes. It's not that they don't vocalize at all, because they communicate and talk and pair bond and all that stuff using vocalizations. But as far as navigation, echolocation for navigation, it is a little to no part of their life cycle at all. And then there's other bats that use it just in passing, very crudely, just occasional calls, 1 or 2 a second. They're even loud. They're not, I don't know if this has happened to anybody else, or if I'm just a freak of nature this way, but you can generally hear bats a lot of times. They're calling it takes a lot of energy to call it a really high frequency, and it takes a lot of energy to call it a really rapid pace. So if you have a really lazy bat or a bat that's in a very simple environment, it'll often be calling down below in the human hearing range, and it'll also be calling really slowly. And so you'll just hear these clicking noises in the air outside on your porch, or night on a summer night. You can hear these clicking noises. So you're actually hearing bat echolocations, but you're hearing ones that are really, really coarse level, that they don't need to have a lot of information about their environment. And there's entire species that really sort of operate at that level, where they're using really basic clicks, akin to like maybe using like a walking stick with your eyes closed and clicking it on the floor and listening to simple echoes to navigate around really large obstacles. So you have everything from super highly evolved echolocation that can see every detail about an insect, including whether they want to eat it or not, and the fact that it's going through evasive maneuvers trying to avoid you, to super basic navigation, which even in some cases are audible clicks, everything down to just using their eyes and have abandoning echolocation altogether.
Thank you, Adam. That was a great answer to that question. Um, so we've got quite a few questions. So Adam and I will try to get through all of them. Adam and I are fine staying on the call longer to get through these. So if folks want to stay on and ask questions and hear the answers, feel free to do so. So the next question, Adams, is how did scientists ever figure out that it was 200 per second? I think that's in reference to the frequency
Yeah.
on your echolocation slide.
Yeah, and actually that's a great question. And there's a very simple tool for that. Being able to listen to calls, echolocation calls in particular, at any frequency is well within our technological ability. And in fact, it's something, you can buy a very simple device to do, even yourself, and go out in your backyard and listen to bat calls. It basically translates high frequency calls to something within our hearing range that you can hear patterns and such. I have an entire other talk only on echolocation because there's such amazingly fantastic things going on with the mechanics of it. They don't just do a simple call, they do what's called swoops, where they start at a high frequency and end at a low frequency, and they're able to compensate for the Doppler effect, which again is like an ambulance or a NASCAR going by you, where you hear the wow, and that's those sound waves being compressed as they get closer, as the sound is moving towards you. And then as this fast object is moving away from you, the sound waves are expanding. So there's all kinds of physics that the bat has to evolve to accommodate. And the rate at which they call is just the very tip of the iceberg with the cool tricks that they do. So it gets more advanced than our ability just to listen to the calls. So how do you know you're calling 200 times a second? We actually can visualize the calls. So we can plot the calls out with frequency. We can see the rate at which the bats are calling, and we can also see the shapes of calls. And this may surprise everybody on the call, but if you're a good birder, you can go out in the woods and know exactly what birds are in the woods because you've recognized all their songs. Bats are the same way. Individual bat species call with a very unique call, and with the sonograms plotted on a screen so that you can actually see the call and what it looks like, what frequency it started at, which one it ended at, what the rate it's calling, you can actually tell species. So it's sort of a little bit like the old Matrix movie where you're watching a series of numbers and shapes go by and you're able to translate that into people and pictures and things. But that's kind of the way bat research works. And you can actually go and look at a screen on any particular night with a microphone and actually tell what bats are flying around at night because their calls are unique to each other from species to species. So more than just 200 calls a second, we're able to get incredible amounts of information out of the bat calls, and we're able to record them and study them as a piece of data.
Awesome. Thank you, Adam. So the next question is, are all 3 species of vampire bats a similar size as the one you caught?
They are, yeah, yes, they are. And they're a pretty good sized bat. They're bigger than most of the insect feeding bats that we have here in North America. The vampire bats tend to have a wingspan of about 16 to 18 inches and are a pretty hefty, sort of sturdy bat. Like I said, they're built for landing and walking on the ground. And also dealing with really other large mammals. So they're not sort of on the delicate end of the spectrum when it comes to bats. But all three vampire bats are very similar to each other. In fact, you'd maybe not be able to tell them apart very easily if you just glanced at them quickly.
Thank you, Adam. So the next question is successful bat boxes in New Hampshire, ?
Yeah,
maybe. Yeah.
Fantastic.
Yeah.
I know it comes up every time, and yeah, it's really important. And it's actually probably the main reason that I put all that information in there about the bat's life cycle. It's really when you're putting up a bat house, you're trying to mimic the conditions as close as possible to what they're looking for. So it isn't just luck, and it isn't just sort of about being in the right place at the right time. If you know the bat's biology and you know what they're looking for, and then you sort of extrapolate that to what conditions are available at your property or house, and then you place a house, you're going to have a much, much higher percentage of it. And so I'll extrapolate to some specifics here really quickly. In most cases, bat houses are summer roosts in Vermont and New Hampshire. They will not be a winter roost. They are not stable enough. Temperature in a bat house in the winter gets far below the 35 degrees that a bat needs. So they're going to be off finding something cold and really stable, something is what's called a lot of thermal mass. It gets to a temperature and it stays there, even if the day is going up and down. So now a plywood bat house generally doesn't have a lot of thermal mass. It goes up and down every day. You know, the sun beats on it for a half hour and then temperature goes up. The sun goes away behind a cloud and the temperature goes down. And specifically, you go into night and the temperature goes down. So that bat house temperature is going to be going up and down all the time. So one of the primary things you can do, because you are basically targeting summer roosting bats, and summer roosting bats, particularly if it's maternity based, want very warm and very stable, is to mount your house somewhere that has a stable and warm temperature as possible. So from an aspect that is south facing or west facing or southwest facing, something that gets good solar gain and solar radiation to keep it warm. And then I would argue this consistency is almost even more important. And you get that by thermal mass. So this may sound a little weird, but putting it over a big slab concrete or an asphalt driveway or something that holds heat and radiates that heat through the night and continues to heat the house can be really valuable. Mounting it to a chimney or a stonework or something, again, that holds a lot of thermal mass and is able to radiate that. Or if you're really ambitious, you can build a bat house with a big bin on the back and you can put it up empty where it's nice and light to do that, and then you can shuttle up buckets of sand and put sand into like an open container behind the bat house that you later then put a lid on, something to give it, again, that sand heats up and then it radiates its heat all night long. So even if your temperature is dropping 10 degrees from your 70-degree day to a 60-degree day, maybe you can get eke out some extra heat out of the sand. So again, all these are just sort of ideas, but if you start with the basic bat biology and then sort of roll that back to where your house is, how your house is built, and what direction it's facing, and even what color you paint it. You want to paint it a dark color, dark brown or black in our environment to make sure it gets a lot of heat. I think you'll see a better chance of getting your house with bats in it than if you just sort of blindly put up your house. I hope that helps.
Awesome. Thank you for that answer, Adam. That was great. So the next question is there a bat cave near Woodstock, Vermont, where we can see bats enter and leave cave at sunrise and sunset?
That's a really good question. I'm not personally aware of any of the caves nearby. I'm sure there are. It's something I just haven't sort of snuffled out on my own. I mean, there are several good exit roosts for sites, and not to, call anything out or anything, but there's a particularly large roost actually at St. Gaudens in one of the barns there, the Beeman barn. And again, not to have hordes of people show up there and it's gated and specific, but at some point, maybe we could have a bat viewing party to watch the bats come and go once we have a little better feel for what's going on there. The part about the question I particularly liked is, can we watch them come and go from the entrance? And that's really important. Again, these roosts are very rare on the landscape because they have to have such specific conditions associated with them. And not only are they rare, but they're very sensitive in the sense that even a person walking through a cave in the winter gives off enough body heat to potentially arouse a bat. And once you've aroused the bat, it can take several hours for them to ramp up to speed so that they may not seem like you're having an effect, but you're actually starting to wake a bat up and you're long gone by the time that bat finally revs up to full speed, is disturbed, and then it takes them that many hours again to sort of cool back off again and calm back down into a full sleep. So disturbance by bats, in addition to sort of the health risks and stuff of being in close proximity to bats and being very respectful from them, watching from outside of a roost is a great way to appreciate them. Yeah, so I'm sorry, I don't know any caves right off the top of my head. Maybe I need to do a little research and come up with a short list of bat-friendly places to go. Yeah, either Fish and Game, State Fish and Game Agency, either in New Hampshire or Vermont, might be able to help you with that.
Great, thank you, Adam. So the next question is, in the Northeast, how common is rabies carried by an individual bat?
Yeah, and I don't have percentages for so I'll tell you, it's difficult in the sense that most rabies data. I'm not in any way sweeping anything under the rug. Rabies is a very serious disease, and bats are major carriers of rabies. And in particular, unfortunately, when animals, not just bats, but all animals get rabies, their behavior becomes very aggressive. It's the way the virus affects the brainstem that they become aggressive and belligerent and actually seek out close proximity to other animals or movement or things around them. They'll actually sort of, and so that they can be very dangerous from that perspective. All that said, coming up with a basic percentage of bats with rabies is super difficult, right? Because all the data comes from the bats that were already infected. You know, there's a higher chance you're going to test a bat that was infected than not affected. You would need to do a random sample of all healthy bats to get that percentage of real background rates. I think a lot of times the numbers that are reported are how many bats that were found in houses or found being aggressive or found biting somebody. Those bats are tested and they generally can come back with a relatively high percentage of rabies. Well, you're subsampling a population that is already sort of predestined to have a higher prevalence of rabies in it because of the behavior which you found them doing when you caught them to test them. So I don't know of a lot of good studies that have gone in and tested at all, a healthy percentage of bat levels. So, rabies is serious. You should basically assume any bat has it is a safe way to do it, and not handle bats in particular. Without at least better to sweep it into a box with a stiff piece of cardboard or really heavy gardening gloves or something like that the bats can't bite through. If you have something that's close, if it's in your house and you're in a position where you have to be able to deal with the bat. So rabies is serious. Rabies is in bats. You should probably assume it's in every bat that is sick enough for you to handle. But an overall percentage, I'm sorry, I can't provide that.
Okay, so we have another question about bat boxes. Adam, you've addressed a good amount on that, but if you just want to add anything to this question, can you talk about why bat boxes are a good or bad idea for conservation, or if they're a good idea for homeowners to have in their yards?
Yeah, I mean, if I'm being brutally truthful, I think they're a fun thing to have around. I think they don't do any harm, certainly, in the sense that they maybe will help people ask questions or become more familiar with or appreciate bats. To low level, they can have good pest control around small orchards and around ponds and that sort of thing. I mean, contrary to popular belief, bats are not really big mosquito eaters. Mosquitoes tend to be diurnal, coming out, at dusk and dawn primarily, not flying around in the middle of the night. Bats tend to specialize in beetles and moths primarily, particularly the ones in the Northeast. Which is not to say those aren't important, because beetles and moths are some of our biggest pest species with regards to fruit trees and crops and all those sorts of things. So from an agricultural perspective, bats play a really important role, and having bat houses in a small local bat population can make a pretty big difference. Bats eat an incredible amount of insects every night, and not too many bats can make a pretty big difference on your local property. Is it affecting, landscape level bat populations and that sort of thing? That's probably doubtful. There's a pretty limited number of species that actually use the houses, and they tend to be the little bit more common ones. So big browns are a common bat house species, and actually little browns are a common bat house species also. And like I mentioned, little browns are currently in a major population decline. So I might have to eat crow a little bit in the sense that if little browns are going to be using your bat box, you could actually be at this point in time in the bat's sort of life cycle and history and population levels, maybe affecting things in a positive way a little bit. But I think the primary benefit is really sort of educational and sort of local on a population level, paying more attention and learning more about them, preserving not only their foraging habitat and watering habitat, but also, the use of pesticides and insecticides, and also their really important bottleneck points where maternity roosts or hibernacula, that, everything else can be perfect. You can have perfect habitat, perfect water sources and everything. And if you don't have a Hibernacula that for some reason it caved in or is disturbed every year for recreation or whatever, that breaks that entire annual cycle and can really affect a really large area for bats. So there's some really great things we can do for bat conservation. Bat houses are, probably is a low-hanging fruit and a great thing to do, but probably not affecting populations as a whole to too great an extent.
Thank you, Adam. So the next question, and Adam, if you need to run, please let us know. But
no, I'm doing great.
Got a few more to get through, and this is going great.
No problem.
So the next question is: do the 3 bats, silver-haired, eastern red, and hoary, all migrate? And if so, where to? My apology if I missed this information.
No, that's a good question. So yes, I mean, yes, they all migrate in different scales. In some, the simple answer is yes, they all migrate, but there's also scenarios where they don't migrate. So red bats in particular are really, really interesting. Red bats are known to often hibernate in the leaf litter. So they're brown and sort of crinkly looking. In fact, when they roost at night, they roost in the open, just perched on a branch. They don't go into sort of any cavity or under tree bark or anything like that. When they're curled up on themselves and they have their tail membrane, which is furred, sort of pulled down over them, they almost look like they basically look like a pine cone. So that's sort of a day roost, but for winter, there's a lot of evidence that they drop to the leaf litter and bury themselves in a deep leaf litter, which gives them some level of insulation, and they can actually bury themselves under snow. Again, with everything being connected, as a really quick aside, we've got, folks maybe have heard of the crazy snake worms and the earthworms in general, the invasive European earthworms. They tend to have a really strong effect on the depth of leaf litter. And it can, it's these incredible connections that Mother Nature has, that you get an invasive worm and all of a sudden you have loss of bat populations. And the connection is that the worm degrades the leaf litter quicker than it can build up. You have no leaf litter, and therefore you've lost one of your roosting and hibernating sites for red bats. Other populations of red bats do move certain distances, sort of medium range. Our longest range migrators are the hories. They're sort of built like a little jetliner. They're big, 14 to 16 inch wingspans, our largest bodied and heaviest bodied bat in North America. And they're flying incredibly long distances. They're flying down into Central and South America in some cases. And in fact, the hoary bat, an interesting fact, is the only native mammal to Hawaii. And at some point, the hoary bat was blown off course on a migration route, and either a pregnant female or a small batch of bats ended up in Hawaii, and they've since established themselves many, many millennia ago. But it's the only native mammal to Hawaii, and that tells you what their flight capacity is for the ability to make it all the way to Hawaii without having to be able to land or refuel in any sort of way. So there's a full range there. I would say the hories are our long distance migrators, typical that they would be going to Central and South America. The silver hairs and red hairs are much more local, to the point where even some of them may be spending time locally, in the sense where they would just move within a mile or two to find a good roost site for the winter. Now, that also sort of highlights how little we know a lot about our species. It's only been in the recent history that we've been able to get our technology like telemetry and other types of techniques where we can follow individual bats down to a size small enough that we can start tracking bats and find out more about their local behaviors. So as that technologies continue to get smaller and the battery life has tended to get better, and the range at which we can listen for them and find them has gotten longer and farther, more and more information has been coming in on sort of their life cycles and daily behaviors and such like that. So I would expect some of these questions about, average migration distances and location roosts and importance of what types of habitats they use. That type of information is only going to get better and better as time goes on.
Thank you, Adam. I never knew that about Hawaii. That's so cool. So the next question is, what structures make the best maternity colonies?
Yeah, again, like I mentioned, a lot of our maternity colonies here in the Northeast tend to be buildings, and that's kind of unfortunate in the sense that putting bats in direct contact with people is just generally not a good idea. It's not really where the bats need to be being, and it's not where we want them to be being. So what kind of building? Unfortunately, buildings probably make some of our best maternity colonies on our landscape currently. And they tend to be really hot attics or eaves, you know, places again where they're stable and warm and protected, and give that. So if you're in a, you know, the idea of creating a maternity colony that isn't a building necessarily can be pretty daunting. I mean, there's folks who've tried it. There are folks who've created bat caves and really elaborate structures all over North America because they really got into it. And it was, I guess, a personal challenge of theirs to create an environment that bats would accept and take over. The other structures, I would say in particular, you guys have probably know this, the bat colonies down in Texas, some of the largest roosting colonies known in North America for the Brazilian freetail, literally tens of millions of bats. A lot of those are in bridge structures. So again, large pieces of concrete over water, large stable, they have slots in them. And in fact, a lot of the Department of Transportation's or the DOT programs, wildlife groups and state agencies have been working with DOT to actually re-engineer bridges to be bat friendly, you know, change small parts about their structure to make them more acceptable to bats. And so that, you know, not only are you building an automotive bridge or a bridge over water, you're building it in a way that bats it's designed for bats to colonize it. So that's kind of a cool thing. So I mean, humans are on the landscape. We're always going to be here. We're always going to have buildings here and structures here. I think one of the really promising things is getting into, you know, engineering these secondary and tertiary uses of some of our structures that let, you know, sort of ahead of time decide that we can all sort of coexist. So, you know, co-designing bridges or co-designing different parts of buildings where the bats can be sealed off from the human aspects of it can really make a difference. You know, on a smaller scale at your house, you know, you can pull off a maternity colony with a simple bat box. You just have to get it so that it can maintain a nice, hot, steady temperature throughout an entire evening, because at night is when the females want to be out feeding, and they're going to, at a certain point, want to need to leave the pups behind. When the pup is really little, you can often find a female flying around with the pup clutched to it, but at a certain size, it doesn't become feasible anymore, and they need to leave that pup. And that bat house has to act like a mom, basically a mother bat, and it's got to keep at the right temperature and the right humidity. And if you were to build a maternity colony or use a box like one, that box has to act like mom, and so you need to take that into account when you put it up.
Thank you for that, Adam. So the next question is COVID/bat ? And maybe I can elaborate and you can address maybe the relationship between bats and coronaviruses.
Yeah, I mean, to tell you the truth, I don't know much about the coronavirus in relation to bat, in the sense that, I mean, I know that it was founded and started in the sort of one of the theories, and I think again I haven't honestly been doing much reading on it. You know, I know one of the original theories was that bats were the sort of the source population for the coronavirus that spread throughout and created the global pandemic that we're currently in. I'm loath to say much more about it because that's the extent I know, and I still know there's some really fierce debate going on by the World Health Organization and the researchers they sent to that area and where that came from. So there's no doubt that wildlife plays a pretty significant role in the introduction of disease into the human population, either through the bushmeat industries or other handling of wildlife or use of wildlife. For a long time, you know, Ebola and the primates in Africa, it was a big connection there too. So it doesn't surprise me that there is a disease vector between particular species in the human race, and that this is one of the latest ones to happen. Like I mentioned early on, bats aren't all that evolutionarily, maybe not as distantly separated from humans as you think. They're not super close, but they're also not super distant. And so the idea that viruses could jump or be evolutionarily designed to work in both their bodies and our bodies is of course realistic and not far-fetched. But yeah, that's probably all I can say on it at this point.
Thank you, Adam. So the next question is, what is the biggest bat?
Biggest bat is the flying fox. And I think they've got a 4.5-foot wingspan. They're really big animals, and they communally roost, so they'll fill an entire tree. It looks like upside down vultures almost, like an old Western with a bunch of vultures perched in a tree over a guy reaching for a glass of water. This basically, you'll see a large denuded trees in the Pacific, South Pacific. And they will all be sort of hanging from these trees in broad daylight, socializing and interacting with each other and jostling each other and calling and stuff. And then they'll fly in these large swarms and flocks through the air during particular times of the day. It's really quite a spectacular event because they're so large. They're so big that they're used as a food resource by a lot of people, especially sort of the native populations have used them as a food resource. So that's how big of a body that they are, that they're a legitimate meat source for that perspective. And the name itself, flying fox, sort of gives you some idea of maybe what you could expect for body size. So yeah, biggest one. The smallest one is the little Thailand bumblebee bat. And I think it's basically about the size of the first knuckle bone on your pinky. So about 3/4 of an inch is in its body size when it's all folded up. So it's a tiny little guy. The Thai bumblebee bat is the littlest one.
Awesome, thank you, Adam. So the next, and I believe it's the last question of the workshop is there a good way to remove bats from your attic without hurting them?
Yes, there is, luckily. It's a great question, and it comes up a lot because, again, bats do come into people's homes quite a bit. Basically, it's called an exclusion, and your goal is to, very simply put, you build a one-way door. You build a one-way door that allows the bats to leave at night and not come back in again when they try and re-roost. And so you've excluded them. So rather than just sort of caulk or seal or foam shut any openings you can, and by that point you've sealed the bats inside the house, and the first thing they're going to do is try and find any way out they can. And a lot of time that means they end up in the living spaces of the house. They'll come down through the chimneys or the cracks or the vents or whatever they can. They'll go towards fresh air or light. So it turns into a really, really terrible event when you seal your house, seal the bats in. So the generally accepted strategy is to create these one-way flaps, which really isn't that complicated. It can be as simple as a chunk of trash bag and some duct tape. Basically, if you have an opening that the bats are coming and going in, you take a 8-inch square piece of plastic or a flap of some sort. Generally, plastic works because it's slippery, and you tape the top side of it like a doggy door over the opening. When bats come through that hole, they just push out through the flap and fly away, no problem. When they come back, they don't have the dexterity or understanding to go back up underneath the flap again. They try and get in around the flap and they find that the hole is blocked. So over the course of a night, all the bats will, over the course of a few days or night, the bats can leave and safely. And by the end of the season that winter, then you can go and foam up all your openings and you can have a good bat exclusion. Now, the only concern or things that you need to work through is that if you do this in the summer, like we've talked about again, understanding the bat biology, is you don't want all the females to leave and leave their pups inside to starve to death. That's something you really want to stay away from. So bat exclusions are best done. If you're desperate to get rid of the bats, you really should wait till late fall, August or September, when everybody's flighted and everybody coming and going from that particular roost can leave the roost. The other option, if you're not in a real hurry, you can wait, is just wait till winter. And all the bats have left at that point. From any heated house will have gotten rid of the bats because it's too warm in the winter to act as a roost. So if you have bats in your house in the summer, almost guaranteed, 100% sure that you don't have bats in the winter if that's a heated residence. And so what you can end up doing is you can just go ahead and not even do an exclusion. You can just seal up knowing that the bats are gone, either on migration or they're hibernating during the winter months. So if you can do it in the winter, do that. If you can't wait till winter, please wait till the young are flighted so that you're not sealing in the pups by letting the female parents leave. Now, in something like a larger structure, like a unheated structure, like a big barn or something like that, where you may have some winter residence going on, you may have to, work with an exclusion. It might be best to do it in the fall when the bats are actually active, because in the winter they're going to be asleep. You're going to seal it. They're going to wake up in the spring, and you're going to have a sort of a real problem on your hands. So I guess what I'm saying is you can contact some local, the state wildlife folks. You can talk to animal control people. And also I would recommend just, reading up a little bit on the bat biology, or like we've talked about today, and with just a little simple thought of when they're flying, when they're not flying, if they're wintering there, if they're not wintering there. I think you can come up with a really good game plan that's generally cheap and relatively inexpensive and can be really effective.
Thank you for that, Adam. I believe that is our last question. Thank you all so much for staying on the call this long. This is amazing. We've never had this many questions, and we've lasted this long, so that's great. Adam, thank you for, as always, an incredible presentation. It's always a pleasure to work with you, and I've learned a lot today. I hope everyone who's attended today learned a lot too. Check out our website. I put it in the chat, the link to it, for information about future workshops, or you can always email me if you're interested in attending a future workshop or just want to learn more. Yeah, thank you all so much. This was a great program, and I hope you have a great rest of your week.
Take care, everybody. I hope the next talk we have is in person where we can actually interact, but this is a great substitute. Thanks, Joey, for everything you were able to do to facilitate this. Take care, everybody. Bye-bye.
Bye-bye, everyone.